Hey everybody, this is a short lesson on how to do how to graph a quadratic function that's in vertex form, which is this new form, and we're going to look at number 3 on homework 12, which is part of your homework assignment. So vertex form is just a different form of a function that's a quadratic function. In the long run, you're still going to have an x squared because this whole thing gets multiplied by itself and you'll get an x squared. It's a quadratic function. And we have the a, the same old a that we had in the standard form. A, if it's positive, the graph opens up. If it's a is negative, the graph opens down. If a has a value bigger than 1, 2, 3, 4, it gets the graph gets narrower and narrower. It gets stretched vertically. If a is less than 1, 1/2, 1/5, 1/10, the graph gets wider and fatter. What vertex form tells us is what its name is. It tells us the vertex. The vertex is at the ordered pair HK. H is just the y coordinate, the x coordinate of the vertex, and K is the y coordinate of the vertex. And notice that this is x minus h, so it's a subtractive format. So once we know the vertex, of course, it's easy to graph the whole function. So that's the nice thing about vertex form is we just look at it and we can tell what the vertex is. When I look at this one, I can see the vertex is going to be at -3, -6. And you're probably wondering why -3? Well, because I have to look at, because it's a subtractive format, I have to write this as a minus, x minus. So x minus -3 is the same as x plus 3. So if I rewrite the whole thing like that, I can see that my vertex, here's my h, and then the -6 is my k. So the vertex is going to be at the ordered pair -3, -6. Okay, so we're going to go and plot that. So we're going to go left by 3 from the origin, 1, 2, 3 to -3, and down by 6. 1, 2, 3, 4, 5, 6. And I'm going to label that as the vertex at -3, -6. And I'm going to dash the line, axis of symmetry line vertically right through that. Okay. So the axis of symmetry line is the vertical line that has the equation x equals this -3. It goes right through, every x coordinate is -3. It goes right through -3 on your x-axis. Okay, so now I look at the a, which is 2. And that tells me that this is opening up and it's going to be a little narrower than the parent function, y equals 1x squared. So what I'm going to do is use my pattern of 1, 3, 5, 7 to graph it, except that I know that's when a equals 1, but in this case, a equals 2. So I'm going to multiply each of these values by 2. So 1 times 2, 3 times 2, 5 times 2, 7 times 2. So I probably only need to graph a few points, but I'm going to be using, every time I move right by 1 from the vertex, I'm going to go up by this many. Okay, so starting from the vertex, if I go right by 1, the first time I'm going to go up by 2. So right by 1 and up 2 and plot a point, and that's there. Okay, then I'm going to go right by 1 and up by 6. 1, 2, 3, 4, 5, 6. So that was there. And I'll go right by 1 again and up by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to be enough points, enough guide points. And now I'm going to reflect those across the axis of symmetry. So with this point, I'm 1 to the right of this axis, and so I go 1 to the left to reflect it. With this point, I'm 2 to the right, so I go 2 to the left to reflect. And with this point, 1, 2, 3 to the right, 1, 2, 3 to the left for the reflection. And then I'm going to connect those for a smooth curve. Now, you know that you could also just make an XY table and take some values of x to the left and the right of the vertex, and use an XY table to get points. But I think the 1, 3, 5, 7 method is pretty easy if you've got good graph paper to draw on. Okay, and at the top of your parabola, or at the ends, make sure that you put arrows to show that this goes infinitely upward. And it's going to spread out and go up infinitely, but it never goes below -6. Y equals -6, does it? So that is going to be the minimum value, which I had to find. So the minimum value we can see is the bottom of the valley, and it's where y equals -6. So it's just -6. The domain is, as all parabolas of this type are, all real numbers, meaning you could put in any value of x into this function and find a point y and plot it. But the range, which is all the possible y values, we can see that the bottom of the valley is here at -6. Y is never going to go below that. You're never going to have a point below that point, lower than -6. So we know that y has to be greater than or equal to -6. So that's how you graph. From vertex form, it's very easy. Just make sure you correctly identify the right vertex and use your pattern to plot points and reflect them, and then take a look at the graph and name the minimum, the domain, and the range. And that's it. Thank you for coming.